What's going on, everybody? It's your boy JT, and today we're going to be talking about an exciting topic: quantum computing. Okay, now this is a mind bender. All right, it's been a theory that I've talked about on LinkedIn for a long time. I'm going to do my best to understand it, but if you don't get it, it's okay. Most of the world is not. It's kind of crazy. And Willow, Google's chip they just made, broke some barriers. Okay, it's not the most powerful quantum computing chip that you may think. I was actually surprised as I did research for this video to find that everyone's freaking out over 100 something qubits, but we've actually broken 1,000 qubits before Willow. So it's interesting to understand the difference, understand what all this means, especially for crypto, because when quantum computing is fully implemented, SHA-256, which is the encryption that protects, or I guess the encryption methodology that is used in blockchain, um, is useless. And it's not just in blockchain; it's in every traditional financial institution. So I mean, the second SHA-256 is rendered useless against quantum computing, basically everything can go up in smoke. There's not a firewall that could protect you or any kind of encryption protect you from a quantum computer, which could cause a lot of bad things in our industry. So I want you to understand it. For those who do not know, my name is Jake Tullis. I go by JT. I run a blockchain specific or a crypto digital hedge fund or a hedge fund in general. And I manage high net worth and private wealth management money in my singular fund, the Advanced Spectrum Fund. And we will always be crypto. And this channel is where I talk about my research that I do for the fund and my capital partners. And the entire goal of it is to bring you guys information so you can be more informed on what this asset class is, what software is, and basically everything in between. Which is why today we're talking about quantum computing. This is a breakthrough in hardware, not necessarily software, but this hardware component is going to enable crazy stuff, especially with AI. It's the kind of futuristic stuff that sci-fi movies is. So why don't we get on over to it? So first, it's important to know that Willow, and actually I want to do this, Willow qubit. Here we go. Okay, so Google just did 105 qubits. Um, so a qubit is essentially, here you go. It's the new way to measure data at a quantum level. So up until now, well, there have always been this concept of a qubit, but every single computer that we use, including the one I'm using right now, and that we've ever used, is bits, right? Kilobytes or bytes, kilobytes, megabytes, gigabytes, terabytes, petabytes, and it keeps going. Qubits are basically the unit of information, as you can see here. So instead of a 0 and 1, which is like an on and off, that's how all bytes work. This is kind of a representation of how electrons and photons are going to help us compute, which is kind of crazy because here's the thing. If we are computing in our current reality that the one that we're in right now, Willow and some other ones we're about to talk about are able to do computations using electrons and photons more than exist in our current universe. The entire galaxy that we are aware of, 105, the computation that Willow did used more than we could possibly have in this universe. Meaning, Willow used electrons and photons in another universe, another reality, because the computation was true. So they de facto proved that we live in a multiverse, meaning there's an infinite amount of universes and realities like ours, which is really, really creepy. And they are using those realities to make these computations because to photons, distance is irrelevant. You could have 10 billion light years between one and the other, And if the state changes here, the state will change there. It's a crazy concept, but we're basically bridging states of electrons throughout different realities, which is like, guys, it's crazy. It's genuinely science fiction. Now, I thought 105 was the limit, and I thought this was like a massive thing. But actually, Adam QC, okay, is has done a lot better. Um, Adam QC qubit. Check this out. Oh man, I just had this result. I should have kept it. It was right around 1100, guys. So it's 10 times qubit limit. Maybe that's what it is. Yeah, see, 1180 qubits. Pretty crazy. Now, check that out. So it's really important to know this. SHA 256 is the standard that encrypts everything, okay? It would take 13 million qubits to crack it in a day. So for everyone in blockchain, what you need to understand is we're probably 15 to 20 years away. Who knows with AI helping us figure this out? From quantum computing being able to break SHA-256 in a reasonable time. Computations is just about how long would it take. So you can think of it like this. If you wanted to hack someone's wallet, you would have to go through every single permutation of every single word in the English language alphabetically. So that's like every A word all the way through, every B word, every C, all the way to Z, and then A, B, all the A's, all the B's, all the A's and the B's and the C's and all the, it's crazy. It's to the trillionth, literally trillions to the 10th possible combinations of words. So thousands and thousands and thousands and tens of thousands of years to calculate what those 12 words would be. Um, Quantum computing can take those millennia uh, down to years. Okay. And once we get to probably a million qubits, not even 13 million qubits, we could probably break SHA-256 inside of a decade. And basically, that timeline is going to go smaller and smaller and smaller. You just throw a quantum chip at that same permutation, and eventually, inside of a day, it could solve it. So, we're far away from that, and it's likely that quantum computing encryption, a different standard stronger than SHA-256, will come out before we hit that theoretical computational limit of, 13 million qubits to do it in a day. So realistically, we're in a scary range when we hit a million to 2 million qubits. Most likely, that's going to cause SHA to be vulnerable to whoever has that chip inside of a decade or less. And once we hit a million qubits, getting the 13 will not take that much time. So maybe we're 10, 20 years away from a serious threat, but for now, I wouldn't worry about it. The scariest concept is all of this proves there's more than one universe, because these qubit limits would not be possible if all we had was this universe, which is kind of really scary to think about. But until next time, I'm going to let you all sit on that. Take care of one another. Happy holidays. Merry Christmas. Love you guys. And tune in soon. Thanks. We'll see you. Peace and love.